Hello, everyone, and welcome to this webcast on utilizing AI and ML approaches to enhance your master data management through the enrichment of attribution and mapping across different data sources. So my name is Brendan Lundquist. I'm a senior data and AI consultant here at Thorogood, and I bring a lot of experience in working with clients in complex data environments that really require the bringing together of internal and external data to derive that insight for your business. So here's a quick look at the agenda for the session today. And first, we're going to just spend a few minutes introducing Thorogood for those who have not come across this before, and then we'll discuss the challenge that we're looking to solve before diving really deep into how AI and ML can be applied to enrich our data attribution and support the mapping of data across sources. And that'll all be accompanied with some demos of these approaches before we wrap things up. So let's first introduce Thorogood a little bit here. Thorogood is a specialist data and AI consultancy firm. So being specialist in the delivery of data and AI for enterprise organizations, we really recognize that a strong business focus is crucial to really deliver the solutions of value to our customers, and that those solutions meet customer needs and are ultimately adopted. And of course, with that, we bring strong technical expertise with a deep data and domain understanding for our customers. We also offer a variety of services, so that ranges from supporting organizations in the definition of their strategy to maximizing the benefit of data and AI, to the definition of enterprise architecture patterns and approaches, and on to the inception design of end-to-end delivery solutions, inclusive of training, empowerment, and support of those applications as well. We're also a global company with offices in the UK, US, Brazil, India, and Singapore, and we're able to support our customers wherever they are around the world. And our customers are typically global, world-renowned organizations in the consumer goods, healthcare and life sciences, insurance, and baking industries. So just to quickly share a range of the customers we work with here on our screen. And we're an independent consultancy. So we're working with the biggest players in our niche specialism and within data and AI. Our independence is something that's valued by our customers, so we can really advise them on the most appropriate technological solution to really fit their particular scenario. So now that you have an understanding of Thorogood, let's introduce the topic and the challenge that we're looking to solve for. So in this webcast, we're going to be looking at two areas that ML and AI, specifically Gen AI, can be utilized. And those two areas are to enrich your data set with new and unique attribution and to really map your various data sets together in order to provide a holistic 360 view across your full data landscape. So just a forewarning here before we get into it, we're going to predominantly be using consumer goods examples throughout, as we typically find that to be a pretty relatable industry, as all of us are consumers and are familiar with these notions of products, customers, and consumers. But the concepts and approaches that we discuss here are equally applicable to any industry operating in any environment of high data volumes and lots of disparate data sources. So the first area that we'll be showing you is how you can take rich textual information like product descriptions from websites like Amazon or others and apply large language models to produce new and novel attribution that can offer unique perspectives on your business and the overall competitive landscape. Previously, the views that we have on our data really relied on internal attribution defined by different analysts across teams or by external data providers. From an internal perspective, that attribution configuration is often very manually intensive to set up, maintain, and align across different stakeholders. But from the external side of things, data providers can also be slow to adapt to the changing external environment, which could really limit our ability to see and assess what could be an evolving business segment. Again, previously, there was a need to really keep up with that fast-paced and rapidly changing business environment, and building in the necessary attribution across the portfolio could really be an insurmountable task. But leveraging some of these new technological advancements, we can take text-rich data to derive attribution that offers perspectives that are unique to you, that provide competitive advantage, and really ensure that you can keep up with those fast-evolving business segments. Secondly, here, we'll be taking you through how you can apply different statistical and AI techniques to address one of the biggest and probably most valuable, but again, one of the most least appreciated tasks in developing data and AI solutions, and that's mapping and aligning data sets from different sources to common business hierarchies. So it's clearly very important to align different data sets to ensure that they can be analyzed seamlessly together for maximizing insights. And traditionally, this mapping exercise has been carried out using mapping files or manual solutions that required analysts to assess any new master data that's coming in and determine the most appropriate member to map to within your common hierarchy. hierarchy. And this too is a very laborious process. So for historical data, this can be a monumental task. And further to that, keeping on top of the new products that could be coming in on an ongoing basis across that full array of data sources can really consume a lot of valuable analyst time and delay delivery of that data to business teams. And now, really, more than ever, we're seeing rich new data sources are emerging based off new digital technologies or otherwise that we want to map and align into our internal data landscape for even greater insight. So I guess just to illustrate this challenge a bit further, we can consider a scenario where a manufacturer has a portfolio of tens of thousands of individual SKUs across different markets, maybe receiving thousands of files from its retailer partners globally, each containing its own distinct convention and codes. Mapping these external codes to that single internal hierarchy for a single source of truth is therefore going to require a significant amount of effort. But again, applying more advanced approaches, we can drastically reduce the amount of time in mapping, ensuring a robust and aligned data set, which ultimately is going to free up time to really interrogate that data for, appropriate insights. So with those two use cases in mind, we'll start with creating enriched data attribution by diving into a specific business case to really frame our approach here before diving into a demo. We'll start with something that we're all familiar with, and that's seeing a particular product description for something that we're going to be or looking to buy online. So again, this relates to the consumer goods industry. It's something we're all familiar with, but this concept of being able to classify rich textual information can be used when it comes to different types of insurance policies or investment products or etc. Here we can see that this product is very rich or has a very rich product description and it's available on the Tesco website. And as a consumer goods manufacturer, I'm suspecting that there are certain segments that are driving growth, but I'm really unable to quantify it from the available data that I have in my product dimension. And one of those segments is the naturals versus artificial segment. So I expect that from this description, I can get a sense of how products could be classified to help drive this particular analysis. In viewing this pure description on the right, we can get a hint, I think, as to where this particular product may fall. Apple cider vinegar, oats, free of sulfates, and so on, right? And reading this single product description, I may lean to the side of natural and would attribute that product as such. But the challenge, right, is when we begin to have tens of thousands of products with their own disparate descriptions, it requires a lot of manpower to have to do that. And frankly, you could miss capitalizing on a trend by the time you finish the full naturals or artificial classification exercise. And also considering having to do that across each emerging segment in your product range and across a full range of competitor products. And it's really just impossible to keep up and respond quickly. And this is where Gen AI and large language models in general can come into help. We're going to head into a demo using Databricks and GPT 4.1 just to show you how language models can help to parse rich text and produce new and unique attribution based on your requirements to create new business segments to better explain what's happening in your industry. All right, so what I have here is an internal Databricks workspace just to show you how we can use AI to enrich our attribution. So I've already pre-run some of these commands for demo purposes, but I'll walk through them to show you how this will all work. So we're going to start with just some general initialization and importing of libraries, but after that, we're simply head right to the configuration of a quick example right here. And you're going to see that this is the same product description that I showed in the presentation previously, and that's that apple cider vinegar shampoo. You're also going to see that I've constructed a bit of a prompt so that the OpenAI model has a bit more direction and steer on the task at hand. So I'm prompting it to fulfill the role as an analyst and to return whether it thinks the product description provided should be classified as an artificial or a naturals product. I'll then set a few more parameters that I'm going to be feeding into the OpenAI API, and as a result, I'm quickly met with what the large language model thinks that this product should be, and that's natural here, right? So this happened nearly all instantaneously, in 5 seconds, right? And when we're working in Databricks too, there's a bit more enabled as part of just working in MLflow, but you can see the system prompt here. You can see the user prompt that I passed to it as well. And you can also see the result returned as part of this product here. It's a natural. So aligned with I as an analyst would have interpreted as well. The large language model has come to the same conclusion. But as we talked about previously, there are potentially tens of thousands of products that we may want to do this for. And not to mention the fact that we could have new attribution that we may want to apply in the future. So we can quite easily write some code here to instead pass in a full product data set as opposed to just a single product very similarly. So again, very similar code here as I'm scrolling down, but instead of passing in the product description directly, I'm actually going to create a function that will allow for the product description within my product table here to get passed to that OpenAI API in the same way, and then have it returned back to the original data frame or table. So if I just scroll down here, we can see that this data frame now has the ID and has the naturals label or artificial label appended to the end of the table, right? So again, this is just an example of a subset of items, but imagine the full set of items that could be coming in, as well as the other dozen or so attributes or classifications that you may want to layer onto your existing product data as well. So again, this is done nearly instantaneously. But to maybe just further cement this point home, with a bit of further data joining, we can really discover that in this particular example, there's a quick trend to see that the natural segment is indeed outperforming the artificial one over the past week. So again, this is just a quick visualization done within Databricks for the sake of this demonstration, but thinking in a production setting, this new naturals label that I've created could be a new feature in your data set and could be analyzed in your data visualization tool of choice like Power BI or Tableau. So just an example, but the way in which you can continue to analyze things will be enhanced. We'll now touch on the data mapping challenge and a layered approach to solving the challenge before going into another demo to illustrate that a bit further too. So the case that we're going to be looking at deals with the positive proliferation of just the amount of data that organizations are able to consume these days. But the amount of different data sources means different hierarchies, different codes, and different perspectives that need to be aligned to our common enterprise view of the world. And we can use AI to help us perform this mapping to obtain that common perspective across all of our external data aligned to our central hierarchies. And once again, we're going to be using consumer goods industry as our example, but the same concept, again, is equally applicable elsewhere too. But in this example, we have our corporate hierarchy, but we also have a slew of other external data coming from our different retailers who are our customers in this consumer packaged goods example. So I've listed a few retailers here, and the list is obviously much more expansive than this. And it also doesn't include other external data sets that we may procure as well, like syndicated data, panel data, planogram data, et cetera, and others. While we can programmatically determine some matches, which we'll get to on the next slide, there are going to be instances where identifiers and codes are different across different data providers, and data may need to even be mapped at different granularities too. So this too is a very tedious process and one that becomes even harder to maintain, particularly with new innovation products and evolving segmentation of products as well. So I mentioned that we can use AI and large language models to perform this mapping, but it's not the only approach and should be used to cover that last mile when it comes to performing an appropriate mapping. So firstly, we want to start with exact matches with simple joins across our data sets. And there could be some small data cleaning operations that we could take to facilitate more matches, but ultimately, this is our most sure way to go about mapping our data sources together with one another. We can then move on to something a bit more algorithmic with similarity matching, and we can use something called Levenshtein distance as an example, which is just an algorithm that can calculate the similarity between two phrases. So if I had a product description that said something like Brendan's shampoo and shampoo of Brendan's, we could reasonably apply some sort of similarity matching that could calculate with a reasonable level of confidence that those products are in fact the same. And finally, after we've exhausted our first two levels, we can move to our third, large language models. And we're effectively asking the LLM to perform the assignment for us based off the appropriate product information passed to it so we can determine the most likely mapping. And as you can see, we're increasing the sophistication of our approaches as we move down this pyramid. And we can also reduce the amount of mappings required too until we can get 100% of all mappings that we need. So what I mean by this is with our level 1 approach, we can say, get to 60% of mappings, followed by 25% at level 2. And as we move down the pyramid here, we're reducing the number of actual dimensional members that we need to map. But we're also increasing the sophistication of the approach and the corresponding computation costs. So where we can capture the mapping through simpler approaches, we can and should do so, and subsequently pass down that reduced set of unmapped members to the next level, with the final level being that large language model. But one important thing to keep in mind with this as well is we always want to be able to apply some sort of overwrite mechanism for our users to ensure that there is a proper mapping across the different levels of the product hierarchy. And we can certainly greatly reduce the effort it takes to maintain these mappings, but we want to be sure that our increasingly complex approaches are still instilling that proper confidence that we need when managing our master data. overall. So what I'm going to do now is, again, show Databricks once again, where we have our next demonstration. So we're going to focus on that last mile of the mapping process, which is the use of generative AI, as well as the other steps, from level 1 and level 2 are a bit more established when it comes to approach. But for a bit of additional setup, I'll be using another product data set that I've stored within what is called the search index. And effectively, our data is now in a format that an LLM can interact with and allows us to really effectively chat with it to get more insight. So if we take a look past this initialization script, we can see that I'm essentially asking the large language model to describe the product data that we have access to. And we can see that within our returned response below. We can see that there is a lot of information returned around the different product categories and even some product examples too. And while this isn't the main point of the webinar, we're effectively leveraging a technique referred to as RAG, or retrieval augmented generation, where a large language model is returning responses based off of our internal data that we have indexed for the model to access, which in this case is our target product hierarchy. So at a high level, in this first example, we've established that I have my target product table established within an index. And that product table is the target for the large language model and what it's trying to map to. And it's queryable using natural language. So just scroll down here within this next example. I'm going to take it a bit further. So in this prompt here, you can see that I'm passing the input data in the prompt just for visualization purposes, but in a production system would likely be reading from some input source and recursively passing into a function, similar to what we demonstrated in the previous demo. But you can also see that within this prompt, I've also given a few other helpful hints on how to behave and how I'm asking it to return a level of confidence in the result it produces as well. And as we chatted about in the slides, my goal here is to really take the information that I have from my external data set in the prompt, pass it to the language model, and have the language model determine which is the best internal identifier, which we've aliased as product SK, or surrogate key, that matches to it from my target data set in the search index. So I'll simply run this code, or I have run this code, and we can see that the large language model has effectively returned what it thinks are the most appropriate matches. So again, just to summarize what this code here has done and what's happened, right? So I've stored my internal product data set in such a way within an index that the data is accessible by the language model. And I've then prompted this language model to perform the task of mapping the external products to its best fit within the internal hierarchy. And by automating this effort, I've reduced the amount of manual effort that would be required, and I've instead leveraged that power of Gen AI to assist with this mapping process. But one thing that you may notice within the screen here is that this mapping process is not going to be perfect. So there are instances where the language model has determined that several external SKU codes actually map to the same internal one, which is possible, right? But in this particular case, it may not be likely. So it brings me to the final important consideration of our presentation here, is that we can't let our AI models run without guardrails, and it's therefore important to introduce a human element into the loop. So we've introduced that tiered approach to mapping, the last mile of that attribution being driven primarily by AI. And whether you've read it in the news or experienced it yourself, there are instances where the language model doesn't always get it right. And this instance, of course, is no different. So one of the ways in which we've seen success to mitigation of this issue is by introducing that human element that can rectify questionable results, which gives that human a final say as to how that product should be mapped. So we can provide a user with information on a mapping on how it was generated, the technique, even a confidence level to help analysts to hone in on the mappings that might be more questionable. So in this example, maybe I would build out my solution to automatically flag anything below a 70% confidence for review by a human, so that we can have that full confidence in what we are ultimately looking to bring together. The technology to do this can be flexible, but we do find a web app interface that can be accessed by key users so that they have the power to decide how they want certain products attributed, and they can ultimately make their decision based off their own understanding and knowledge. To conclude, in this webcast, we've presented a situation that we really consider to be an ideal use case to leverage the power of machines and apply AI. And the value of getting it right is massive. And aligning all of your distinct business data sets to common hierarchies unlocks massive potential and insight. And leveraging text-rich information to understand new business dynamics and segments really presents a unique perspective to identify opportunities for your organization to grow rapidly. And humans are certainly capable of assessing new source data and working out the suitable mappings to your business dimensions, but doing it across thousands or tens of thousands of data files for thousands or even hundreds of thousands of distinct members and keeping up with that on a daily, weekly, or monthly basis really requires a huge amount of time and a delay in actually making the data analysis available. So by maintaining and creating mappings and attribution, it just requires scale that may even be beyond what's possible in most organizations. So to conclude, we could really apply AI and Gen AI to automate the work in ways that wasn't previously possible, which frees up time for our own team members to actually analyze our data for insights. And finally, we can make sure to keep humans in the loop, to keep that check, and to inspire the confidence and the trust in the management of our master data overall. So that's it from our webinar here from me. I did just want to conclude this session with an offer to those viewing to not hesitate to reach out to hear about their good experience and really how we can help. So our experience with our customers is ranged across many different areas of data and AI, and we're happy to discuss these technologies and concepts further. With this, we've come to the end of the webinar today. Hope you're able to benefit from the session a bit. Please feel free to reach out for any additional detail or questions they may have on the session, and I'm more than happy to chat about it. So thank you and have a great rest of your day.